Good morning, everybody. My name is Laura Goulvent. I am the technical manager for Lamothe Abiet winemaking products in the US. I'm working for Booker Vaseline North America. So Booker Vaseline North America is not only selling winery equipment, we also do coastal bottling lines, Caso pumps, different types of pumps. We recently started distributing Dujardin Saleron laboratory equipment. We also do fruit processing and, of course, Lamothe Abiet winemaking solutions. So Lamothe Abiet is based in France. So it's in Bordeaux area. It is the first winemaking product company that has been developed more than 150 years ago. This company is focusing on using natural-based products for any part of winemaking process, from grapes processing to bottling. And today we're going to focus on enzymes. So we're going to focus on enzymes and how to improve wine quality and productivity using enzymes. Enological enzymes are a group of enzymes that are used by many winemakers to aid in extraction, but they are natural. We see enzymes everywhere in the living world. We were able to select them and work with them a little bit more seriously, I would say, from 1950s. Firstly, enzymes were used to increase juice yield and improve clarification. So that was more for orange, apple juice. And then the commercial enzymes were adopted by the wine industry in the 70s. Today, as winemakers, we use enzymes for clarification, but also to improve filtration, to enhance aromas, or even to block malolactic fermentation with lysozyme. So here's the program of today. So we're gonna go back to the basics. So what are enzymes? What is an enzyme? How it is produced? We'll see like a little bit basic information, but very important information to understand how they work and how we can use them. And then we'll see different categories of winemaking enzymes, such as enzymes used for clarification, filtration, kind of the same families of enzymes. Enzymes used for extraction, but also aromatic extraction and mouthfeel. And then we will end this webinar by some practical tips and question and answer. So please, if you have any question, you can write your questions in the chat, and I will try to answer them by the end of the session. So, enzymes, as I said, are naturally present in all living systems. They are proteins. They're specific proteins. They are not synthetic chemicals. Enzymes are therefore not actually produced, but they are extracted from growing certain microorganisms, mainly in fermentation systems. What do? Is that they have a catalytic reaction. So that means that the enzymes facilitate or accelerate reactions. They have a particular structure for a specific substrates and a specific activity. So one enzymes will be adapted to one or more specific substrates, and then it's called the enzyme substrate complex, and then through catalysis it will be able to transform something or to cut something, especially in the wine production. So this is the concept of enzymes. So here are the main enzymes we can see in wine, in the grapes. As you can see that they are naturally present in grapes, but also in certain microorganisms. So for example, pectinases are contained in grapes, but they're in a very small amount. And this is a very small amount that we can't really use them for winemaking practices. What do? Is that they break down pectins to improve juice yield and clarification. They are mainly in skins. We can see also cellulase from grape skin and pulp that degrade cellulose. We can see also hemicellulase, proteases, glycosidase, and lacase. So lacase enzymatic activity is actually not found in the grapes, but in Botrytis cinerea, this fungi. We can see usually this on damaged grapes, botrytized grapes, so it can cause oxidation and leads to browning and further oxidation or of aromas, etc. So that's different types of enzymes that are actually natural, that we know they exist, and that producers extract from other growing microorganisms. So how do we do to extract and to use enzymes for production winemaking? So as you see, enzymes are all present in all living organisms, but to exploit, to develop enzymes, we're using microorganisms or microscopic fungus or bacteria. The main source would be Aspergillus niger. There are at least 10,000 different known strains of Aspergillus niger. Aspergillus aculeatus, Trichoderma arsianum, and Penicillium are also renowned microorganisms for producing enzymes. So what we do is that we select the different strains, we do fermentation, optimize fermentation to actually select specific enzymes with targeted activities and side activities. And then we have two choices, or we just select one type of pure enzyme activity. For example, just separated and selecting pectin liase activity, which will help us to have a higher concentration of this enzyme. It's specifically chosen for high efficiency and fast action. Or we choose to select and separate a blend of enzymes, which has then a broader spectrum. For example, for improved filterability, you will need to target more than one specific spot in the pectin chains. For example, if you want to do extraction, that's also the same. You need some secondary activities and a broader spectrum. It really depends on what your target is into the winemaking process. Something very important to know is that enzymes are usually dependent on dose, quantity, temperature, and time. So meaning this, and a little bit of pH, but wine pH is usually fine for enzymes, and especially winemaking enzymes. So that means that if you don't have enough time, then you can work with increasing the dose or increasing the temperature. Or if you actually have time, if you're using a maturation enzyme and you have 6 months of aging, then you can decrease the dose. And so usually the temperature, you can't really modify that. So, but that's something very important to know. I will go further into these details later. So each particular enzyme has a specific structure, and we have four different type of activities we're looking for in winemaking. So today I'm going to talk about clarification enzymes, but also filtration enzymes. They are from the family of pectolytic enzymes. We also have enzymes for extraction that are very useful in winemaking, but also we can use enzymes for aromatic expression, so developing more volatile aromas, and also to build mouthfeel. So that we see that you can use enzymes from the beginning of the process of your wine to the bottling, pretty much. But they will have very different activities. So this is a large table. It's a little scary, but it's just to show you the different types of enzymes and how we can use them. So in the pectolytic enzyme activities, we have the polygalacturonase, pectinliase, methylesterase that are more used for clarification, but also extraction and to improve filtration. So this is the type of enzymes you can use for these objectives. You can also use hemicellulase or cellulases for extraction, but also improving filtration or improving mouthfeel. Glycosidase will be used for maceration, extraction, but also to release some aromas. Same concept there. And glucanase will degrade glucans, so that will help to improve filtration, clarification, but also glucanes. So I'm going to talk about these different families during this presentation. So let's go. But first, there is something to know about enzymes is the level of, excuse me, excuse me, the importance of purification and how to prevent side effects. So all our Lamothe Abiet enzymes are purified from cinnamoyl esterase activity. So what is it? So cinnamoyl esterase activity is an enzymatic activity that can transform ester tartrates into acid phenols. And then the acid phenols, if you are fermenting your wine with a POF positive yeast, or bread can also transform acid phenol into vinyl phenol. This is then how you get vinyl phenols, and then these vinyl phenols can be transformed into bread taint, ethyl phenols, volatile phenols. So yeah, some paint, nail polish, farm aromas and smell from the Brettanomyces. So many enzymes on the market are have this cinnamoyl esterase activity, and this is very important because it really depends on grape variety and if you use a POF positive or POF negative yeast. But you can risk to have more of these vinyl phenols in your wine. So it can be very impactful for your wine. Talking about POF positive yeast, so that's just yeast that can transform the acid phenols into vinyl phenols. Just so you know, all our Lamothe Abiet yeasts are actually POF negative, so they don't have this capacity to transform, for example, caffeic acid into vinyl catechol, and this is very important. We don't want this activity happening. So, for example, if we look at control wine and the addition of two enzymes, so enzyme X is a competition enzymes. We just did a comparison just to see what this if this enzyme had this cinnamomyl esterase activity. We can see that compared to the control and the use of enzyme crush, one of our yeast of our enzyme, it actually created more acid phenols. So more caffeic acid and caphtoric acid. So that can be impactful for the aromatic complexity and can create off aromas. So all our yeast, all our enzymes are purified of cinnamomyl esterase activities, because this comes from Aspergillus niger activity when we extract the enzymes for that. So we remove this secondary activity to avoid the stimulation of the formation of volatile phenols. So first, let's talk about clarification and filtration enzymes using pectinase and glucanase. So why do we want to clarify? So clarifying musts, so usually people would, well, some people would press and then let their must settle overnight, or even less or even more. It really depends, from 12 hours to 2 days. What is very important is that you improve the so you remove the turbidity, you improve the clarification, so you don't ferment on a high turbidity must, because you can then have a lot of reduction or oxidation in your must. It will also improve fermentation capacities because your fermentation will be healthier. It also helped you to remove any oxidized component or any phenolic compounds that are easy to oxidize, and any green or herbaceous compounds. So how do you clarify? How do you clarify your musts? By just reducing viscosity. You want to act fast. You can then break down linear pectin chains using different types of enzymes activity. You also can improve clarification by using fining agents. So talking about the pectin chains enzymes, we have three major enzymes, which is the pectin lyase. So pectin lyase is a very quick and good enzyme to reduce the viscosity very fast. It does quick clarification. It's also very useful for flotation. That's the enzyme you want to use for flotation. And so the pectin lyase, so you see, the pectin chain is like a necklace with different pearls. So what does the pectin lyase? It's gonna randomly cut this pectin chain. So it will cut in between two pearls, for example. So it works very well, very quick, but it's not very specific compared to the pectin methyl esterase and the polygalacturonase. So pectin methyl esterase will cut the chain at specific spots. And same for the polygalacturonase. Those two activities are working together. They are way slower, but very efficient to make smaller pieces. So these are very strong enzymes for settling or filtration, for example, when for filtration you want to cut into more small pieces. So clarifying enzymes, you want to use them, add them at the press pan or into your pressed juice. You don't want to use it in the in the press to avoid your grapes to be mushy. I would definitely use it, add it directly on must, and I would suggest a contact time of at least 30 minutes. So how do you know if you have pectin or not? How do you know if you need to use pectinase or if your pectin enzyme was efficient enough? So you can do a very easy test, which is called the pectin test. It's 1 part juice and 2 parts of alcohol. You wait a few minutes and you will see if your pectin test is negative or not. So the more pectins you're gonna have, the more flux or heavy flux you're gonna have. That means that you have a medium presence of pectin or a high presence of pectin. This is a very easy test to do, but it's essential if you want to make sure your juice is well clarified, but it can also work before filtration. For example, if you have a struggle filtering your wine, if it's clogging, you don't have a good flow, it might come from the pectins, or it can also come from glucanes. But doing this test can actually save some cartridges or time for sure. And then you will be able to use an enzyme to actually cut these pectin chains and remove any pectin that can impact your clarification. It's also important to use a pectinase before fermentation on must, because usually pectin is so in presence of alcohol, pectin chains are more condensed and are more resistant to hydrolysis. So it's easier also to clarify and impact your pectins before fermentation when there is no alcohol or not, or even at the beginning of fermentation. So Lamothe Abiet solution, we have one clarification enzymes for must clarification. It's a mix of different pectolytic activities. It has a lot of pectin lyase activity, so it gives a quick and strong clarification. It is very strong, very resistant to low temperature and to alcohol. So you can even use it after fermentation for filtration improvement, for example. You can use it for clarification and settling. It will help you to have a fast settling. Of course, it will really depend on your grape variety and the quality, and if your wine is very turbid. Some grape varieties are more than others. I know that in the past we had issues settling and clarifying some Sauvignon, so that would be a good solution. For flotation, it works well. So you can use this enzyme, so it's low dosage, it's from 2 to 4 milliliters per hectoliters. So what we see on this graph is the use of 2 different enzymes. So the yellow is the control, just the difference of turbidity over the time at a temperature of 42 Fahrenheit. So we see that the control remain very turbid, very cloudy, not very clarified. And we can see that after 2 hours using Enzyme Clear at 2 milliliters per hectoliters, the pectin test is negative. That means that it was very quick, very fast in a short time, compared to the enzyme V, competition enzyme, that was way less efficient and productive. So with the enzyme clear, that means that you can even lower the dose. If you have time, if you have more than 2 hours in this situation, you could have just use, for example, half dose to achieve a pectin test at 0 after, let's say, 4 or 5 hours. So yeah, it's very efficient and quick. That will help you to have a better tank rotation if you need to use tanks quickly. So if you want to rack off the lees of must and just start the fermentation quicker, then you can use an enzyme like this. It will help you to just be more productive and reuse tanks and start fermentation quicker, which is pretty interesting. Then let's talk about another type of clarification enzyme, which is more for filtration. It is called ENOFlow Max. So we suggest to use it for more filtration because it has a very broad spectrum of enzyme activity. So it's a mix of pectolytic enzymes, but also beta glucanase, and will be active on everywhere on the pectin chain. As you see, it does have arabinogalacturonase, so can remove the AG2, also the arabinase. It contains some pectinases, the pectin metylesterase, polygalacturonase, and pectin liase. So will help to cut this necklace of pearls into very small little pieces. It does contains also hemicellulase and beta-glucanase. So it's not only impacting the pectin structure, because of the beta-glucanase, it also help to cut and to degrade the glucanase, so the glucans. Glucans can come from botrytis, damaged grapes, and can impact the filtration very badly, but it can also just come from other bacteria. So you want to make sure you use a broad spectrum enzyme with secondary activities before filtration, so you impact everything. So then filtration flow will be better. You improve your flow, your filtration rate, and you get way better yields. So this enzyme, you can use it on must, but also on wine during aging, or if you have a filtration issue, then you can act quickly and use this. My suggestion is that if you have time, then you don't need to add too much enzymes because it will slowly do its reaction. But if you have less time, I would increase the dose rate and maybe increase the temperature, but it really depends on your production. Then this is some trials about Enoflomax. So that was on a Merlot. The contact time of Enoflomax was 3 days. We added 10 milliliters per hectoliters, and that we see that after 3 days, the turbidity of this wine, it was a finished wine, was decreased from 321 to 92. That's a lot just using an enzyme. And in terms of Vmax, so Vmax is the maximum filtration volume a wine can pass through a membrane before complete clogging. So in simple terms, it tells you how filterable your wine is. You can see that the control, you need to do pre-filtration on your control to prepare your wine, maybe do a fining before being able to actually do a filtration of your wine, compared to the wine treated with Enoflomax, which has a very high filterability. So it's not gonna impact or clog your filters, and it's just gonna be easily filterable without having to spend too much time preparing this wine and having to spend a lot on wine movement, pre-filtration, etc. Okay. Then Second very important enzyme is enzyme used for extraction. Here is a very interesting drawing of the skin and the composition of the berry. So we can see that it's a matrix of cellulose and xyloglucanes hemicellulose, and the pectin matrix is the other way. So we can see that it's a huge structure, because it's very useful for the berry to remain strong and intact over the season. But what we so it's another drawing showing the structure of a berry. So we have the skin in red. So this contains more tannins and anthocyanins. So the skin of berries contains the color, the aromas, but also the structure, the different types of tannins. We can also, of course, find tannins in the seeds, but that's not the most qualitative tannins we want to extract in our wine. So we can see that in the skin, we have the thicker cell walls, very thick, with complex pectin matrix, as we saw on the first picture. We have branched pectin chains, but they are also rich in cellulose and hemicellulose. So all the components we want to extract are also very difficult to extract compared to the components that are found in the pulp in the berry, where you can see that thin cell walls. They are mostly linear pectin chains, so way more easy to extract. So you need to find solutions to make this pectin matrix break to be able to extract more tannins, anthocyanins, and polysaccharides. So we've been doing a trial, so using the coloration of Schiff. So Schiff test coloration, it's just a colorant that you're adding in your cell. And as you see, what is in pink is the polysaccharides present in the cell walls. So you see that they're really everywhere, and they're really kind of stuck in the cell walls everywhere. We compared this Schiff test colorant by using another competition enzyme. And what we see is that colors are not everywhere. There is only a selective hydrolysis of some cells. We can see that there are some polysaccharides just in some areas. So the enzyme didn't break down all the structure. It didn't release all the polysaccharides everywhere. There is a large portion of unbroken cells walls near the skin, so that's limiting the extraction. Compared to using enzyme crush. So enzyme crush broke down the complex of the pectin matrix, but also the linear pectin. So we can see that it acts on the flesh, but also it really helps to break down all the skin cell walls. So you can see that there is pink kind of everywhere, but it's way more qualitative, because it's not creating the berry mushy or very destroyed. It's really targeting the skin. So the berries are just way more easy to extract during the extraction process and during the fermentation. So what we can see by using an enzyme like the enzyme crush is that it will improve the phenolic and color extraction from the skin without making the must overly mushy. And we also see after that that it does release more aromatic precursors, but also polysaccharides, as we see there, to enhance more mouthfeel, but also color stability and wine complexity. So, enzyme crush. So, enzyme crush is a liquid preparation of pectolytic enzymes from Aspergillus niger. It's non-GMO. It is highly purified from cinnamyl esterase activity and anthocyanins. So it's not going to degrade color anthocyanins. It's highly concentrated. You can use from 10 to 30 milliliters per ton. You can use this enzyme on grapes. So I would suggest using the enzyme on berries when you can, as soon as possible. So you can spray the enzyme on your beans, on your grapes, or you can also do that after destemming or in the press pan. But I would definitely do some layerings of enzymes, so the enzyme is well distributed. So why using an enzyme crush? So enzyme crush will help you to gain more qualitative juice. So from 3 to 9% of more free run juice yield. It will release more aromatic compounds. We'll see that later. Polysaccharides. So polysaccharides are responsible to a lot of nice things, I would say. So being able to release more polysaccharides will help your wine to be more protein stable. And for sparkling wine, you will have a better foam stability, but it also helps stabilizing the color. Tartaric stability also is help, and also it will improve the mouthfeel and the roundness in the palate. It will also extract more phenolic compounds and color. So early extraction of tannins will help your wine to stabilize the color more early in the process, because usually the anthocyanins are extracted way more easily because they are smaller molecules and hydrosoluble. And then during the fermentation, when the alcohol is increasing, this is when we extract the tannins. But in order to stabilize the color, do better combination between tannins and anthocyanins, it's actually very interesting to be able to extract more tannins at this stage, so your color will be more stable. And then it will help to clarify and improve the filterability of your wine. So using these enzymes also will help you to shorten macerations. If you do white maceration, pre-fermentary maceration to extract more aromatic complex, but also for red wines, more color, tannins and aromas, it will help you to shorten this because your extraction will be way more fast. So talking about color and phenolic compounds, here we can see a trial made on Cabernet Sauvignon, where we compare a competition enzyme to just a control where we didn't add any enzyme, and enzyme crush at 30 milliliters per ton of grapes. So first we can see yellow, red, and blue. That's the different absorbance of color. So we can see that using enzyme crush increased the proportion of red color. So you extract more redder color, but also you extract more tannins. So that's the green dots. As you can see, there is way more total polyphenols extracted, so more tannins extracted that will be more available for stabilizing the color. So just by using an enzyme on grapes, you can see that you extract more tannins from the beginning and more color compared to not using enzyme or some competitor enzyme where it did almost nothing. So it's very important to do trials, to select your different enzymes and to observe the different results. Then what you can extract also is aromas that will help to extract more precursors of aromas that are situated in the grape skin. Here we are talking about sciols. That was on Sauvignon Blanc. So we can see that we almost double the amount of sciols from a control. Yeah, even more, plus 121. So you will result with a wine, fermented wine that has more aromatic complexity just by using this enzyme on grapes. You can use this, this will work on white wines, but also on red wines, because a lot of red wines are full of sciols too. It's just gonna enhance the varietal aroma's complexity. Then, using an enzyme, extraction enzyme like the enzyme crush, can also improve the qualitative juice extraction, meaning that it will extract more free-run juice. As you can see in green, the control in the left has around 44% of free run compared to the enzyme crush use. We were able to extract a little less than 60%, maybe 58, 59% of free run compared to the total amount of juice. And so this can be a game changer, because you can definitely reuse more the free run. And in total, there is, in this trial, we had 2% more of juice. We also did, we were able to do cost comparison. This is just based on the gain of more free run juice you have. So let's say if you have 3% more free run juice in total in your wine, if you compare just with not using the enzyme, you can see that you can just basically get more money from what you're making. So we did the calculation between 3 different types of wine. We based our study saying, if we produce a $5 per gallon wine, what do we earn if we have an increase of 3% of free run juice of wine? We can get $128 more, with, of course, the cost for treating 10,000 gallons of wine remain the same. It's going to be $22 for 10,000 gallons. So it's almost nothing compared to what you gain. So if you have wine that costs $15 per gallon, then you gain $428. And for premium wine, then you can go up to 900, like a little bit less than $900. So in any case, you reimburse the cost of the enzyme, you extract more aromas, you extract more color, your color is more stabilized, and you extract more polysaccharides, so more mouthfeel, and you gain more juice. So it can be a real game changer in your process. That's that's a good way to optimize your process and improve your wine. Talking about wine improvement, enzymes can also be responsible for aromatic expression. There are two types of enzymes for this. They are the beta-glucosidase that will help to transform from precursors into volatile aroma, some norizoprenorids or terpenes. This family of molecules are more responsible to floral notes, violet, rose, peonies, but also spices like black pepper, uh, chili sometimes, or fruity aromas like cherry, or can be also some papaya aromas like this. And enzymes like carbon sulfur beta lyase will release siols, so sialic compounds such as 3MH, 3-MMP, BMP. These aromas are more in the family of tropical fruits, citrus, boxwood, blackcurrant bud, but also BMT is a siol responsible for more minerality, let's say flinty aromas. So first, let's look at the siol metabolism and reminding the pathways. So in must, in the berries, the aromas are under the form of precursors. They are odorless, we don't smell them, and actually to transform them into something we can smell, you need some enzymes activity. Usually the yeast is doing this transformation from precursors into volatile sales, into aromatic compounds. So we need a carbon sulfur lyase that will convert the precursors into volatile sales. And then the yeast will be also able to transform the 3MH into A3MH. But even with a very good siol yeast, a yeast that has a high conversion rate of precursors into volatile siols, the yeast can convert from 15 to 20% of the volatile siols. That means that there are still a lot of precursors that could be released into more aromas. So this is why we developed this very specific enzyme that does exactly the same enzymatic activity as the yeast, but will release way more aromas. So this enzyme is called enzyme siol. It is a liquid pectinase with beta lyase and beta glucosidase activity. It does express siols precursors, but also release terpenes and norizoprenorids aromas. So you can use it during the fermentation to exactly do the same action as the yeast do, but also you can using during aging or just before bottling, because you know that you still have some aromatic precursors of siols. Let's say you have a Sauvignon that is not very expressive, that needs to have a boost of aromas. Just even now, if you're preparing to bottling, you can use enzyme siol and it will release more volatile siols, more siols in your wine. You can use it on white wines, but also on red wines. It works great on Cabernet Sauvignon, Sangiovese, Syrah, Merlot, Pinot Noir, to develop more aromas. And on white wines, that would be more the siolic varieties such as Colombard, Sauvignon, sometimes some Pinot Blanc, all this. pecorino, for example, this is the trial we see. So just comparing a control and the use of enzyme cells, we used 5 milliliters per hectoliters. We can see that we improved the aromatic complexity and the amount of cells in the wine by 24%. So that's a lot. So just a very nice way to just convert what your grapes has naturally into more aromas. Another type of enzyme is the enzyme FW, fruity white. So it's a blend of pectolytic enzymes with beta-glucosidase activity. It does release terpenes and noisoprenoids compounds. So basically, it will cut the chain between the sugars and the aromas to release the aromas and make them more aromatic. So it will increase aromas on white, rosé, and reds but it's gonna more focus on floral profile and fruity profile. It does also help clarification and filterability because of the presence of pectolytic enzymes. And this activity can be stopped by bentonite. So you can use it during fermentation, but also same concept, you can use it during aging and pre-bottling. If you want to try the enzyme style or the enzyme FW, please send me an email or ask me, because this is a very fun trial to do and very easy. You just get some samples of your wine, let's say lab temperature, so your temperature is a little higher, so the enzyme activity will be faster, and then you add the enzymes and wait, let's say 1 week, and then taste your wine and see what the result is, if you like how increased the aroma complexity is. So yeah, let me know. This is a powder enzyme also, so very easy to use. And in this situation, I would suggest using this enzyme for Riesling, Muscat, but also Chardonnay, Gewürztraminer, Viognier, so more terpenic grape varieties, but also works very well on Syrah, Grenache, Cabernet Sauvignon, Corvina. So that can be very interesting if you need to improve freshness or more aromas, if your wine is a little hot, to rebalance your wine. So talking about aging and final balance of your wine, here we're going to focus on mouthfeel. So how can you improve the mouthfeel? You can we've been having amazing results with the Vinotest Pro. So the Vinotest Pro is a purified enzyme. It's a blend of pectinase, beta-glucanase, protease, and arabinase. So it has a broad spectrum. So it will help you to have a faster maturation and a better quality wine. Because first, because of the pectinase, it will improve the settling and your clarification. It will also improve the filtration because of the pectin activity, but also the beta-glucanase. If you have glucans in your wine, that will help to cut this and improve the filtration. But also, because it's degrading the glucanase, it will release more polysaccharides. And polysaccharides, it's like so will reveal and break down the glucanes from yeast, for example, the yeast compounds on the lees you have. For example, it's just the basic concept of autolysis, just the release of more polysaccharides, more roundness and complexity by breaking down the cell wall of yeast and then releasing more monoproteins and polysaccharides. That means that you can shorten the aging time or have more roundness, density, and cleaner time. And it also helps to improve the stability of your wine, color stability, but also tartaric stability and protein stability. So you can cut maturation time by nearly 20%. So yeah, it's a very interesting enzyme to enhance the flavor profile and the mouthfeel, just adding roundness and volume. And just also, it's not written, but it doesn't have the cinnamyl esterase activity, so no risk of off flavors because of this yeast. So on this trial, that was a tasting, just tasting the same wine, one with no enzyme and another wine with Vinotaste Pro, wine aged on lees, and the panel of tasters definitely preferred the Vinotaste Pro. Same, if we look at this Merlot tasting, the wine seems way more dense, same amount of tannin, but more length in the mouth and less dryness. So same amount of tannin, more density, more bolder wine, and more elegant. So that can be a very interesting enzyme to try if you need a little bit more mouthfeel density for red or white, but or even rosé. So last but not least, so I would suggest using enzymes as early as possible in winemaking for clarification, but also you really need to find the enzymatic activity you really need, because they have such different types of activities for specific actions and application. So I would definitely select highly purified enzymes and follow the vendor's description and really look at the enzyme activity. They can be a very good tool if you want to improve your wine quality, but also save some time and some money. So because it will increase yield and good yield, so more furran juice. It will extract more specific compounds such as aromas, color, polysaccharides, and improve the filterability. You can increase the quality and the efficiency, meaning that if you shorten maceration, if you start fermentation quickly, if you can have a better rotation of your tanks, if you can decrease the maceration time or the maturation time, then you can save time, manipulation of wine, and money. So the application of an enzyme is really dependent on the dose, the temperature, and the contact time. If you don't have time, you would increase the dose or the temperature, or if you have a lot of time, you can decrease the dosage. So take-home message. So for clarification, you can use Enzyme Clear, works very fast and quickly for settling your must and clarify it and remove pectin. Enoflomax has a broader spectrum of action, so it will impact the different chains of pectin, but also glucanes. So it's really good for filtration because it has a very broad spectrum. In terms of extraction, we have one enzyme that works for white, rosé, and whites and reds. You can use the Enzyme Crush, very efficient. you can beneficiate from it a lot. For aromatic expression, so releasing more aromas, so you can use enzyme sales if you want to focus more on freshness and sales, or enzyme FW for more terpenes and non-rhizoprenoids. And for mouthfeel improvement and aging, so for more lees work, you can use the Vinotaste Pro. Just a few notes about bentonite. So bentonite can deactivate the enzyme. So it's important to delay the bentonite addition to allow the time for the enzyme to react. Same with tannins. I would not suggest to use tannins and enzyme at the same time. For example, if you're using tannins on red must, I recommend to add the tannins first at the crush pad and then add the enzyme after with the first tank mixing, for example. So there are little tips like this, but if you have any question, you can definitely ask me. I will be able to answer your questions.